Welcome to module 23 of database management systems. We have been discussing about application design and development, and this is the third and concluding module in that regard. In the last module, we have discussed about different aspects of application architecture, rapid development process, issues in performance and security, and took a glimpse in terms of what is required for doing a mobile app. In this module, we will take a case study in terms of a library information system. We will try to design the schema for that. As you have seen that for a database application design, there are front end designs, there are middle tier business logic design, and there will be issues in terms of the database design. Since we are in the DBMS course, I will not focus on the whole aspects of application design, but we will focus specifically on the database aspect. So, we will start with a basic requirement specification for a library information system, and then from the starting from that we will try to extract different entities and attributes and their relationships, and we will make a relational schema and use different notions of dependency and how to write queries. We will look into those aspects and refine that and finalize a schema for this problem. So, let us work through that. So, the module issue is library information system. So, let us start with a basic, this is a very small description. So, but yet it will give us lot of food for thought in this work. And while you actually go through the rest of the video, I would suggest that you take a printout of this page or keep this page separately, because you will frequently need to refer to it. So, let me quickly go through this. We are talking about an institute library that has over 2 lakh books and over 10,000 members who can use regularly issue the books on loan and return them on the expiry of the period or before that. And the library needs a library information system to manage the books, the members, and as well as the issue return process. So, we are just looking into these aspects, not the procurement of books and organization of the books and so on. Now, what is given? Every book has its title, author, publisher, etc., a number of different attributes, ISBN number, accession number. In terms of a book, I must explain to you at this stage that any book that that is published has an ISBN number, which is an international number given so that you can uniquely identify that book. So, if we are talking about the database management book we are following here, then that has a ISBN number, but that does not mean that number actually is unique for the book, not for a specific copy of the book. So, if you buy 3 copies of the book and put it in the library, then these 3 copies need to be identified separately by another number, which is typically called the accession number. So, naturally the LIS need that every book has ISBN number, which says which book it is, and the accession number, which says which specific copy it is, because there may be multiple copies of the same book in the library. On the member side, there are 4 categories of members, broadly students and teachers, but among students there could be undergraduate, postgraduate or research students and the faculty members. The student are specified by their name, roll number, department, gender, mobile number, date of birth, and the degree that they are doing, and every faculty member also has a name, employee ID, department, gender, mobile number, and the date of joining. The library, to manage these members, library also issues a unique membership number to every member, and every member has a maximum quota for the number of books that she or he can issue, and the maximum duration for which those books can be retained once issued. So, there are different specification for different categories of member can have different quota and different duration. The general rule as specified by this library is a book may be issued to a member. Naturally, if it is not issued to someone else, the book has to be available. Also, a book may not be issued to a member if another copy of the same book is already issued to the same member. So, you cannot issue 2 copies of the same book at the same time. No issue will be done to a member if he is kind of a defaulter, that is the time of at the time of issue one or more of the other books already issued by the member has already exceeded the duration of the issue. So, they are overdue for return. In that case, no issue will be allowed. No issue will obviously be allowed if the quota exceeds. And it is also specified that wherever we talk about name, every name will have two parts, the first name and the last name. So, this is the given specification. Based on this, we will need to make a good relational schema to represent the tables and manage the queries. So, let us take a quick look into some of the sample queries. This is just an indicative sample. Now, naturally, we need a whole lot of insert, delete, update kind of queries for adding or removing members, categories of memberships, the books and so on, adding, removing or changing the quota of a category of member, the duration for that. Also, we will have queries like to check if the library has a given book with a given title, and if it is found, then the details of those should be listed. We need to check if library has a book given its author. So, if I say the author, it should be possible to look at a book. We should be able to check if a copy of a book, if I specify the ISBN number, then whether it is available with the library for issue. So, there may be, as I said, multiple copies of the same book. So, given the ISBN number, it will return all the copies, the accession number of all the copies and their issue status, whether they are issued or they are available. It should be available, it should be possible to check the quota, available free quota of a member, and certainly it should have features of issuing a book to a member, and this should check for the rules of the library as stated. It should be possible to return a book and so on. So, these are the typical queries against which, in the backdrop of which we will try to design the database system. So, what we will do, we will initially start with the specification as given. So, I hope you already have kept a copy to refer to, and we will try to extract the different entity sets and the attributes. Naturally, the first entity set that we extract, we let us call it books, which is about books, where in the beginning I have given the basic statement that is given in the specification. So, from that we can see that books will be an entity set, and it will have attributes like title, author name, which is a composite one because it will have two parts into that, the first name and the last name, the publisher, year, ISBN number and accession number. So, these are the attributes available for books. So, this is our first entity set. The second entity set are students. So, this is the statement about the student, and from that statement we can easily extract that entity set here is student, and the attributes are member number, because certainly in the context of the library system, as I said, the student has to be a member. So, it will be, there will be a member number which has to be unique, the composite name. The student has a roll number. So, we are assuming that that roll number is an unique field. So, no students will have the same roll number. Then there is department, gender, mobile number, which could be null, the date of birth, the degree that the student has done is doing. So, those are the different attributes for this entity set. So, we have books, we have students. Similarly, we will have faculty. Again, this process will continue by extracting different parts from the specification. So, this is a statement about the faculty, and we know that there will be a faculty entity set with attributes like member number, name, ID and so on. So, it should be quite obvious. Library has talked of that it will issue unique membership number to every member, and there are 4 categories of member. So, let us we are just making a tentative suggestion that there could be. So, it looks like members are an entity which the library has to interact with in terms of issue. So, let us create an entity set members which has the member number and the member type. So, which can take different types of undergraduate, postgraduate, these different one of these 4 specific values, let us say. The rules have talked about having a quota. So, every member will, according to its member category, will have different quota. So, to represent, so quota becomes an entity set. So, we would like to represent that for different member type, which is a category, how many number of maximum books can be taken and what could be the maximum duration. So, let us say we will put the maximum duration say in terms of months, and with these 3 attributes we will have an entity set which is quota. Here I am talking about another entity set staff. If you again carefully read the specification, you will find that there is no mention of this staff in the total of the specification. But if we logically think, and this is what we often need to do when we deal with a practical specification like somewhat like the one that I have given here, is that we would need to look little beyond the specification. So, think about it, if I have the library with books, students, faculty, issue process, quota and all that, then certainly there will have to be some staff of the library who will actually do all this operation. So, they will be able to log into the database and actually issue a book, return a book, check for validity and so on. So, let us assume that we have a entity set staff, which certainly a staff should have name and ID, which ID should be unique, gender, mobile number and date of joining. So, this is kind of a speculative addition to the design of entity sets, and this must be ratified from the customer when the opportunity arrives, but something like that must be there for to make the design complete. So, these are obviously the immediately visible entity sets that we see. So, the other part that we will now have to check on is the relationship. So, again we pick up the relevant statement in this regard. Books are regularly issued by members on loan and returned after a period. The library needs an LIS to manage the books, members and the issue return process. So, certainly there will have to be a relationship of issue between the student or faculty and the books. So, we loosely define this relationship. On one side there has to be the books, and the other side would be the involved entity set would be either student or faculty. So, actually though I am just noting it here as a single relationship, but actually there is a relationship of issue between students and books and faculty and books. So, we will have to see how to handle this kind of situation. Now, certainly the students or faculty are identified by the unique member number of the library that has been given. Books, as we have said, are identified by the accession number. Again, please note that we are not talking about the ISBN number, because ISBN number could be same for multiple copies of the book, but when you issue a specific copy. So, that accession number, which is a unique for a specific copy, needs to be tracked. So, these are the 2 attributes which will certainly be involved in the relationship. And then you would recall that often relationships have their own attributes. So, here we have one. The date of issue needs to be recorded, because we want to check conditions like if the borrower has issued the book and for how many months he or she is keeping that book. So, if we have to check that, we need to know when the book was issued. So, this is an attribute which does not exist in any of the entity sets that are involved in this relationship, neither in students or faculty or in books, but this is a attribute of the relationship which needs to be specified. And of course, this relationship is a many to many relation, because every student or faculty can issue multiple books and every book may be issued by different, but we can in general we can be specific to say that this is many to one also, if we want to maintain that at any given instant a book can be issued only by one person. So, if you look at it from that perspective, this will not be many to many, this will be treated as many to one. So, having done this having found out these entities and attributes and the relationships, let us now start with a relational schema. So, what I have done here in terms of the relational schema, that for each of the entity set I have created a relational schema by the same name and have put the attributes as identified as attributes of that relational schema. So, this is a very straightforward. Once we have made this identification process from the original specification, this is a more straightforward process where you just convert every entity set into a relational schema. And also we have converted the relationship, there was a there is a relationship called book issue here, as you can see the book issue. This also we have converted to a relational schema involving the two attributes of member number and the accession number. So, let us see how this will span out in later parts. So, having done this, the next task would be to work on the refinement of the schema. So, now it is time that the relational schema is available, the first schema is available. So, now we have to apply all different notions of the relational design to refine this schema and finalize. So, for what we will do, we will take every relational schema and we will try to identify the functional dependencies and use that to identify the key. So, if I look at the books relational schema, then we easily know that ISBN number will uniquely identify the title, author's first name, author's last name, publisher and year. So, here also you may just note that since name is stated to be a composite attribute, I have designed here to use two different attributes, the first name and the last name. So, with that we have this functional dependency, which tells me that given the ISBN number I know these details, but of course, that does not tell me what is the accession number, because there could be multiple copies, but another functional dependency must hold, because every copy of the same book must have the same ISBN number. So, given the accession number, ISBN number should be determinable. So, accession number functionally determines ISBN number. So, if you do the simple computation on this, you will easily figure out that the key of this is accession number. So, this is what we currently have, this is what we have done. Now, so you can see that if there are say 5 copies of a book having different accession numbers, which are the key, their ISBN number would may all be same. So, if I have the same ISBN number, I can have multiple accession numbers, and therefore, there are different records, but if the accession number of 2 books are I am sorry, the ISBN number of 2 books are same, then all of the title, author and first name, last name, all these attributes will be repeated. And if there are multiple copies of the book, then each one of them will have a separate entry, because they have a separate accession number, but their ISBN number and everything else will be redundant. So, we can easily see that the given relational schema actually has redundancy across copies of the book. And if we want to look at this from our formal theory, we can easily check that the key is accession number. So, ISBN number determining title, author, etc., that functional dependency violates the Boyce code normal form. Actually, this is also not in the third normal form right now. So, we would do well to reduce this redundancy, and it will be good to normalize. So, here I have not gone through the actual steps of normalization, but I am showing you more intuitively as to how you can normalize, because it is quite obvious that the accession number is involved only with the ISBN number, and which keeps track of the copies. So, we propose to have under normalization, we propose to have one which is let me just highlight and show you. So, book copies where the ISBN number and accession number will be maintained. So, for every accession number you will be able to see the ISBN number, which will tell you which book it is, and the rest of the book details will be kept in this, say another new relational schema called book catalog, which will have all of the earlier attributes except the accession number. So, now if you project the this dependency on book catalog, the dependency will be fully projected. So, the whole dependency is preserved. If you project this dependency on the book copies, it will also be fully preserved. So, this decomposition is dependency preserving, and you can easily check that these two can be joined by a natural join using ISBN number as the common attribute. So, if we take the intersection of the two sets of attributes, then ISBN number would be the attribute, and ISBN number functionally determines all attributes in the book catalog. So, our lossless join condition R1 intersection R2 determines R1 here. So, this will also give me a lossless join, and if you check on each one of these relational schema, then this functional dependency, the left hand side is a key, and therefore, book catalog is in voice code normal form and book copies is also in voice code normal form. So, you could come to the same result by doing the formal process of functional voice code normal form decomposition, but I have just shown you here as to intuitively how you get there. So, intuitively it becomes very clear that you have details of the book that you keep separate in a separate table, because that will not change across the copies, and you have a separate table to maintain the specific information about the copies. So, that takes care of the books relationship. Moving on, let us look at the other. So, book issue is a relational schema which comes from the relationship between now between what? Now, book issue has to happen between student, faculty and books. So, it is, I mean, we cannot have two of them of these entity sets occurring in the same. So, initially let us just put that, well, the library has a concept of a member. So, what if the book issue is a relation simply between the members and the books. Of course, we do not know the relationship between members and students or members and faculty, but we can at least refine the book issue to be between member and the book, and therefore, member number and accession number together becomes the key which determines the date of issue. This is already in normal form, as you can see. Quota is a simple relational schema where member type determines the max books and duration, and that is the key in normal form. The members, I mean, we have identified something like a member which should list all the members of the library. So, existence of a member number in that list will mean that someone holding that member number is actually a member, and it should also tell me what type of member or what category of member he or she is. So, member number must determine the member type, and the member type will be constrained in terms of one of the 4 possible values as stated here. Now, of course, we will still have to figure out as to where do we get this member type from and so on, that information is not present here. So, further refinements will be required in this regard. Let us go to the students. This is the whole schema that we had done. So, roll number determines all the attributes, specifically roll number also determines the member number, and member number determines the roll number, because every student has a unique roll number and obviously has a unique member number also. So, member number and roll number both will determine each other, and roll number will determine rest of the all attributes, which mean that this design, this relational schema has 2 keys, the roll number and the member number. Okay. Now, are we happy with this design? That is a question we need to ask. So, we can figure out that member number is needed for issue return on queries. Book issue has member number, that is what we were thinking of. Now, when we want to deal with this book issue, issuing a book to a student and returning a book from the student and so on, is it necessary to have all the students' details with that? Won't that make every record very heavy? And if we want to connect with that, do some join, or if we want to do some query, unnecessarily we will have to deal with very large units of data. And as we will see in the next couple of modules, that if a record becomes larger, dealing with it naturally becomes more cumbersome. So, there is some kind of discomfort at this design. Similarly, a member number is not here, it is a student relation. So, it is coming from the student relation, but in general in terms of issue it may also come from a faculty relation. So, how is that handled? We do not know. Then issue return also needs a member type, which is implicit here in terms of the field in terms of the attribute degree, which tells whether the student is an undergraduate, postgraduate or research, but it is not explicitly maintained anywhere. So, these are the issues in this form of the design that we keep. Moving on, look at the faculty. You have a very similar situation as of the student. The ID determines all attributes of the faculty. Member number is also determined from ID. Member number in turn determines ID. Every faculty has 2 unique numbers, 2 keys, and we have similar type of issues as we have seen in terms of student. So, we will need to do something in terms of this. So, what can we, what kind of issues we will get into? So, let us consider a query that the query is to get the name of a member who has issued a book, say having accession number, some accession number 162715. Now, if we have to write a select query for this, we will need to know whether the select query should be written on the student or with the faculty. So, if this member is a student, then we need the first query where we do a join between student and book issue to find out the student member number who is issued that book, where the accession number gives me the particular book issue record from where this result will come. Similarly, if the member is a faculty, I need a different query. Now, it is a problem, because if I have 2 possible queries and based on the member number I have to decide which query to fire, we have not done any mechanism like that. So, this design has problems. So, let us see what we can do. So, we again go back to the specification and see what did the specification say. It said that there are 4 categories of members: undergraduate, postgraduate, research scholar and faculty members, and leads to that leads to the specialization of this relationship. And we have already done a members concept, members entity we did, which has the member number and the member type. But now we have just seen that it actually matters as to whether the member is a student or is a faculty is a more unique deciding factor in terms of how we design our query. So, we introduce a new attribute which was not specified explicitly, say let us call it member class, which can take only 2 values, either student or faculty, and then retain the member type. So, what it will mean that if the student class is student, then the member type could be UG, PG or RS, and if the member class is faculty, then the person is a faculty, then the member type should be only FC. And then also maintain the roll number and ID in this members table. So, the roll number obviously if the member class is student, then the person is a student and the roll number will exist, but the ID, which is an employee ID, will be null. And at the same time, if member class is a faculty for a record, then the roll number will be null, because the faculty cannot have a roll number, but the ID will be present. So, we extend the members entity set and relational schema with these attributes, and once we do that, then we kind of exploit a hidden relationship which was not very explicitly stated anywhere, that now we can say that student is a members, faculty is a members. That is, from the perspective of issuing books and using the library, both students and faculty can be considered to be members. It is kind of a virtual entity that we can see here, and certainly there will be a one-to-one relationship between the students and members and faculty and members. So, let us see what is the consequence of that in terms of the earlier query. So, if we go back and look at the query again, we will see that our problems have got significantly solved, because we now still have to find that member name, and this is the basic condition which say with this is a basic condition which say specify the member number who has issued that book. But the actual problem of finding the name can be solved here, because I write 2 queries and take a union of the first query runs on faculty, the other query runs on student. Now, here since I have a member class which tell me whether the member is a faculty or the member is a student, so one of these queries will actually return a null result. It will not return any record, because it will not match this condition, but the other one will match and will give me the record, give me the corresponding names, first name and last name of the member. And certainly to ensure that when we are looking at the faculty, we need to check the equality of member ID between the members relation and the faculty relation, and while dealing with the student, we need to check for the equality of the roll number. So, in this way, by using intelligently using the union feature and the nested query feature, we can easily write a query, and where implicitly now based on the data, the switching of which table I am actually looking the data from will get solved. So, with this refinement, my members schema now turns out to be member number, member class, member type, roll number and ID. Member number determines everything. It member type also determines member class, because if I know some member type is undergraduate, I know the member class is student and so on. Key obviously is one number. So, having done that, we again go back to the students and faculty, because now we do not need the member number in that anymore, because these will not directly be involved in the issue return, because all that you need is just the member number, which is already there in the members. So, now it is a roll number which determines everything. Member number is no longer used, and member type and member class, which we have assumed exist in the members, will have to be derived from the degree value at the time when a new record is created. So, when a new student record is created, an entry will happen in this relation, as well as a corresponding entry will need to happen in the members relation, where the membership number is given and the membership type will be derived from the degree. Similar change will happen in terms of the faculty as well. So, after refinement, now we have these 8 relational schema from book catalog to give the details of every book, book copies which gives the information about what are the different copies, book issue is the basic issuing information. We have quota, members has the virtual kind of relation that we have created to support the notion of members of the library, and students and faculty are related to these members either through roll number or through ID in a selective manner, and staff we have not touched. So, this is the final relational schema. So, in this module I have shown you, illustrated you that how starting from a very simple specification you can reason and work through in terms of creating the entity sets, attributes and relationships, and then get into the relational schema, look at the possible functional dependencies and refine that, and also look into what will be the requirements of doing your query and come to a final refined schema. So, various queries that we had talked of and others can now be coded on this, but I will leave that as an exercise to you. Please try out coding those queries, and you will be able to learn in terms of how to do that well, and I will try to also supply some supplementary information on this offline.